Hey, hello there, and welcome back to another video. So, yesterday I was playing around with my Advent of Code 2022 solutions, trying to squeeze out some performance and trying to optimize, trying to make things run as fast as possible. And I stumbled upon this this solution for day 16, and in particular with this function that I didn't like very much, but I didn't want to refactor it while I was playing around with performance optimizations. So basically this is a function, a recursive function. You can see that it calls itself inside of this loop. And there are a couple of problems with it that make me not like it so much. And I was thinking, well, maybe I could give a try to rewrite it as an imperative function or an iterative function instead of a recursive one, and see if I like it better. And well, maybe I wasn't thinking about making a video out of this, but why not? Let's give it a try. So, okay, I probably don't want to explain too much about the problem at hand here. But let's explain on a high level what this function does. So this puzzle was about navigating a series of caves, or well, each cave has a valve. So you're going to see that this problem refers to this valve thing very often. And these valves can be opened, and when you open them, you release some pressure, and you basically want to see what path do you have to take. And by the way, these valves are also connected in sort of a graph. So you basically want to see what path do you need to take in order to open some valves and release the highest amount of pressure. So what this function does is basically that, kind of a depth-first search through all of the valves, trying to open them in different order and see which path releases the most amount of pressure. In this given, you're given like a given amount of minutes. So in each minute you can walk to another valve, and it takes a minute to open them, and so on. So that's more or less what it is about in this puzzle. I guess we don't need to go into much more detail than that. So let's discuss what I don't like about the function, which are a couple of things. The thing that I don't like the most is this parameter here, which is a mutable reference to a hash map to keep track of all the max release pressures. This thing basically, I think, should not be a parameter. It should be the return value of this function. But since we are making recursive calls to, this function is making recursive calls to itself, it needs to pass around this thing if it wants to modify it. And we are modifying it here at the beginning. We are taking an entry to this and saying, okay, if the current released pressure is greater than what we had here, we are updating that. Okay. And let's look at the calls to this thing. So in the main function, this run thing, we have a bunch of code, and then we have basically two calls to this for part 1 and part 2 of the puzzle. So on part 1, we are calling this function with 30 minutes, and we are basically creating an empty hash here and passing it through to the recursive function, so that then the recursive function populates this thing. And again, I would like to, instead of passing it here, I would like this function to return me, this thing. And we're doing the same thing for part 2, except that on part 2, the only difference is that we are simulating 26 minutes instead of 30. And then we are doing some weird thing that we don't need to worry about here. Okay, so that's the first thing that I don't like about this. The other thing that I don't like is this context parameter here, which if you see the type, it has a comment justifying its existence, but it's a terrible justification, I think. This thing only exists to bunch up some structures to avoid passing too many parameters around. So basically this context is these three data structures for keeping the valves, the distances between the valves, and some bit mask things that we don't need to get into. But yeah, these are basically three data structures and three things that don't mutate or anything that we need in this visit all paths recursive function. And in order not to receive these three things and then pass them just the same in the recursive calls, I just bunched them up into this context. But this is a terrible name. It could be called stuff, and it would convey the same amount of meaning. So I would also like to get rid of this thing if possible. And finally, maybe the third thing that I don't like about this function is that it's also receiving some parameters that, for the outside calls, they don't make much sense. These two last zeros that we are passing are the open valves bit mask and the currently released pressure. And the open bit mask is this bit mask type that is just an integer. And what we are using this bit mask for is to keep track of which valves have been opened. So each valve has a specific bit that it flips when we get open, and this is basically a very efficient way of keeping track of which valves are opened at the current moment. And yeah, so we know that when a valve is currently open, we don't need to visit it again, basically, and that's it. But from an outside perspective, these things don't make sense to pass. I think these things should only exist inside of this function and have a simpler signature to call it for calling it from the outside. So okay, let's try to rewrite this as an imperative function. So the first thing that I want to try out is to not have this mutable reference here, and instead make this the return value of this function. So we are going to yank this from here, and we are just going to have inside of the function, the first thing that we are going to have is a mutable variable that is just going to be initialized as a hash map, as an empty hash map. And at the end, we are going to just return this thing, max release pressures. Okay. Yeah, so that's the first bit. Then let's get rid of this. Well, no, this is complaining because now, okay, the recursive call doesn't make sense because it no longer takes this. Maybe let's get rid of this. What's your problem now? Okay, a mismatch of types. We can probably get rid of that with that. Okay. So now we have to make this recursive call into a loop, basically. And the secret to transforming a recursive function like this into a loop is basically to reify the call stack into an actual value. So instead of keeping the state of things implicitly, or not implicit, but on the call stack, we're going to keep it in an actual stack variable, which we are going to just simply call stack, and we are going to use a vector for this. And we are going to initialize it with an initial value, which we are going to think of what we need to put there. For now, let's just keep, let's put an empty tuple there. And what we are going to do is basically have a while loop where we are going to pop from the stack. So we're going to do stack pop, and we are going to assign this into a variable. So while there is something on the stack that we can pop, let's call this thing a state. We're going to keep popping from the stack, and let's move everything that was on the recursive function inside of this loop. And instead of calling the recursive function, we're going to push things into the stack. Okay, let's first think of what do we need to have in this state. And basically what we need to have in this state is what we have on each call stack that changes between each call stack. This is basically the parameters to this function. So we are going to be moving between different valves, so that is going to need to be on the state. The amount of remaining minutes is also going to change from time to time, so we can see that, yeah, on each, maybe we can see it in the recursive call. So in the recursive call, we keep the same context that we received, but we are passing another valve here, which are the valves that we can travel to. We're also passing a new value for the remaining minutes, and we are also passing a different bit mask, that is the bit mask that we received as a parameter, or with the bit mask associated with this other valve that we are going to visit. So we are going to mark that valve as visited doing that. And then the release pressure that we are passing on the recursive call is going to be the currently release pressure plus the release pressure corresponding to this new valve that we are opening. So okay, basically it's these four things that we are changing between each recursive call. So I guess that is the four things that we need to put into the state. So for this, I guess we could define like a state struct and basically put these four things here, and then start this with an empty, like with an initial state and putting some things here. But I think instead of like defining a struct for this, I'm going to be very lazy and try to just use a tuple for this. And let's see how it looks. So okay, we have these four things. So for the current value, and by the way, let's also finish fixing the signature of this function. So the context, yes, we are still going to take the context. Instead of a current value, we are going to receive an initial, I was saying value, but it is current valve, and we are going to receive an initial valve of type valve ID, yes. Instead of receiving the remaining minutes, we are going to receive the total minutes that we want to simulate here. So let's call this total minutes. And we are not going to receive these two things, the open valves bit mask and the remaining pressure, because these are basically internal things to this function. So this is going to be the signature now, much simpler than before. And did I screw? Yeah, okay, we have some syntax problems here. This tuple we need, the current valve, or well, this represents the initial state that is going to be into this stack. So the current valve is going to be the initial valve, of course. The remaining minutes is going to be the initial total minutes. So we are going to start with total minutes, and then we are going to be decreasing the amount of minutes on each stack push. The open valves is going to be 0, which is basically what we are passing here. The bit mask and the initial release pressure is 0 and 0. So this initial state corresponds to what we are passing in these initial calls to this function. Okay, so yeah, we're initializing the stack with that. And now the states, I probably want to destructure that. I actually kind of want to have those names. Okay, so the first thing was the current. No, not currents. How are we calling this? The current valve. And also the remaining minutes. The third thing was, I should have kept the parameter list there. The third thing was the open valves bitmask. And the fourth thing was the release pressure. So, okay, what we do here is we have a state, which we pop from the stack, not the stash. And what's your problem here? Not stack. Okay, so we are popping this state from the stack, we are destructuring it. Then we update, I think this is the same as before, max release pressure. I guess we can call it something more succinct. Max pressures. We update this thing. Then we have the for loop where we are iterating over all the other valves that we can visit. And this is basically the end of the termination condition. We are calculating if we don't have enough time to visit this other valve because the distance +1, the +1 is because we need 1 minute to open the valve, is greater than the remaining minutes, then we don't have enough time to visit this valve. Or if this valve is already opened, which we calculate by checking the open valves bitmask with the bitmask corresponding to this valve. And if they don't overlap, that means that it's not open. Or sorry, if the if the open valve bitmask has that bit for this valve turned on, so it doing AND with this is different than 0, then the valve is already open, so we don't need to visit and we skip this thing. Otherwise, we calculate the new remaining minutes, which is the remaining minutes that we had, minus the distance to that valve, -1, because we are going to take 1 minute to open the valve. And okay, that's it. But instead of doing the recursive call, we are going to do stack push of this new state. And the new state is going to be just a tuple without the context. But I think the tuple is going to be just the parameters that we had before. So the new valve that we're visiting, the new remaining minutes, the new bitmask, and the new release pressure. And I think that's it. And I think that was all for changing the function itself. But we did change the signature, so we need to fix the calls now. So on these calls, we no longer need to pass this. Let's try to do some multi-cursor editing here. We don't need to pass this mutable variable, nor these last two things. Okay. And the return value of this, so we don't need to have this thing as a separate parameter, and this won't be mutable now. So okay, that looks much better than before already, at least the calls to this. So let's see if we actually get the same, well, if this actually runs. So if you do cargo run, I should have made run this thing before making the change. So let's run this thing for day 16 in release mode and see if it runs. Okay, it did run, and these are the answers. I don't know if those are the correct answers, so let's actually stash these changes. Let's go back to the previous version before changing anything and rerun the thing again. I think they look like the same answers. Yeah, okay. Yeah, they are the same numbers as before. So now we have the initial version of the code, and running that gives us the same answers. So let's stash pop. And okay, that was it. That was the change from, oh no, there's one extra thing, the context. Yeah, I wanted to get rid of that. So yeah, now that we are no longer doing recursive calls to this, I think the context can just go away. We're going to yank this from the context, remove this struct, and instead of passing this context, we are going to pass these three things. And maybe actually I want to pass them as the last parameters, so that these two things, the valve ID and the total minus, are the actual interesting parameters to this function, and the rest is kind of like constant things that we need to compute the max pressures. So, well, we are not going to pass these vectors as smooth, so these need to be references. Okay. And now, instead of building this context like this, let's yank these values from here, remove that context variable, and well, let's do some multi-cursor editing again. Let's see if this works. We're going to remove the context and add those parameters at the end of the parameter list. And if we save that, okay, and also we need to pass references to this. So reference, reference, and reference. And that was it. And of course, now inside of this function, we no longer have the context parameter. So let's just remove this thing. And we have these things as parameters now. So again, also the code inside the function is now a bit cleaner, I think, without accessing that context and just having the distances right away and valves and all of that. Okay. This should still run the same way as before. And it does. And I think the change doesn't affect the runtime, or not that much. Like, okay, we are using a dynamic data structure for this that is going to allocate things on the heap instead of using the stack for this, but I don't think that is much of the... Usually, that doesn't make a lot of difference on the runtime itself. But yeah, I think I actually like this change. Is there something else that I wanted to change? Okay, I did get rid of the mutable parameter, get rid of the context, and now I think the signature of the function does make more sense. We can see that we are calling this for part 1 and part 2 with the same initial valve ID, but with different minutes. And yeah, the rest of the parameters are the same basically, but we don't need that nonsensical context thing. Okay, I think I'm all right with these changes. Let's actually look at the changes and compare. So okay, definitely the calls to the function look much better now. We don't need the context variable that we had before, and we don't need to have this mutable hash map that we were passing on as a mutable parameter for the things to fill in. Instead, we are calling the function, and the function itself is returning these max pressures, which is nice. We no longer need this struct. My cat is sleeping below my computer and is moving it. Yeah, I have my laptop with a raised platform, and my cat likes to sleep below it. Okay, where were we? Yeah, okay, and then the main bulk of the code is a little bit more indented because now it lives inside of this while loop, but it's not too bad. And I think it's, yeah, overall, I think I prefer the while loop version because it's easier to keep track of, for instance, the things that you need to share between iterations of this while loop, like the max pressures and the stack, but mainly this max pressures. Now it's like more explicit that it just lives inside of this this function call, and yeah, you don't need to be passing it around or anything. It just is there for you to access. So yeah, I think I prefer this version. So let's commit it. Convert day 16 recursive function into an iterative. Recursive depth, let's call it depth first. Graph traversal into an iterative loop. Traversal function to an iterative loop. Okay, that's a bit of a long commit title, but I'm okay with it. Save and commit. And yeah, I think that's gonna be it for today's video. Probably let's do a fun thumbnail for this. So what did we do today? We converted a recursive function into an iterative one. So let's call this thing, say toilets recursion. And I want some new line here, so let's use this bash syntax. Recursion into iteration, and I want to write iteration with some colors, so let's use the Mono 12 font for this, and let's write toilet iteration, and with the same Mono 12 font, and pass it to lolcat. While that didn't go as intended, I need to also pass the T option for it to use the terminal with recursion into iteration. Actually, maybe let's make the recursion part a bit smaller. I'm liking this. And what if we add also like a sad smiley face, crying smiley face to recursion, and to iteration we add some badass glasses. Oh, I screwed something up. Oh, of course, I'm having another quote here. Let's escape this. I don't like those glasses too much, but this is starting to look cool. Let's clear the screen. And let's maybe put this like after the ellipsis. Oh, look at that. Actually, it looks quite nice, I think. You know what? I think I like this. Let's leave the comment as the first. Maybe the colors there. I wanted to run it with have a run of lolcat that gives me nice colors. Oh, I like those colors. Okay. And you know what? This this font for the recursion into part reminds me a lot of the like Evangelion font for some reason. This is totally off topic, but if we search for Evangelion episode title, yeah, look at this. I don't know, for some reason it reminds me of, yeah, this kind of format, everything to the left. Yeah, I don't know. This is a recursion into text reminds me of that Evangelion titles. But yeah, that's how to transform a recursive function into an iterative one. At least simple cases like those that you can do with a stack. And that's it for this video. So if you have been, thanks for watching and see you later. Bye bye.